All right, guys, today we're going to be going through the Unit 6 review. Again, this is all about Unit 6 similarity. So we're going to see quite a few different problems that we've seen throughout the entire chapter. Again, very important that you guys study this for the test. So with that being said, let's go ahead and jump right in. Now, our first problem, again, we have 12 problems total today, and we have a calculator over on the right side if we need to use it. Our first problem tells us to find the fourth proportional to 1/2, 3, and 12. Now, if we recall, whenever we're naming out these proportionals, they're always written in a very specific order. First is in the top left, second is in the bottom left, third is top right, and fourth is bottom right. So since we have these three terms, these are already in order. 1/2 is first, 3 is second, 12 is third, and then we're trying to find the fourth one, so we'll call that fourth one x. So again, we have 1/2 over 3 equals 12 over x. At this point, we need to go ahead and solve for x. So we cross multiply, and that will give us 1/2 x equals 36. Now, I need to get rid of this fraction. So again, this is the same as x over 2 equals 36. Well, how would I get rid of a fraction? We multiply by the reciprocal. The reciprocal of 1/2 is just 2. And of course, if you saw this fraction, you'd be like, oh, I multiply by the denominator. It's exactly what we're doing here. I multiply both sides by 2, and the denominator will cancel, leaving us with x equals 72. And that would be our fourth proportional. So that would make this equal to each other. Of course, to get from 1/2 to 3, I'd need to multiply by 6. To get from 12 to 72, I'd need to multiply 12 by 6 as well. All right, let's try out our next one. Find the ratio of x to y. So we have 7x equals 10y. Now, for this problem, again, it gives us the ratio of x to y, which means that our fraction will be x over y. So our end goal is to have x over y in our final answer. And that needs to be on one side of our proportion. So the first thing I'm going to do is I want to get this y underneath the variable x. So I divide both sides by y. That'll leave me with 7x over y equals 10. But I still have this 7 out front. It's being multiplied by the x. I need to get rid of that. Well, how can I get rid of multiplication? Division. Dividing both sides by 7 will give me x over y equals 10 over 7. Now, this is exactly what we were looking for, x over y. We found it. From here, we're just going to go ahead and put each of these numbers into our answers. The numerator goes first, so we have 10, because again, that's matching up with x. And then y will go second, so 7 will go second here. So our final answer is 10 to 7. Let's try another one out. This time we have 5 over 4x equals 8 over 5y. Again, we want to solve the ratio of x to y. So we want our final answer on one side of our proportion to be x over y equals our answer. So to start this one off, of course, once again, we're given a proportion this time, and we know how to solve proportions. We just cross multiply. That'll give us 25y equals 32x. From here, again, it's very similar to the last one. I want to get y in my denominator. So I divide both sides by y, and that'll leave me with 32x over y equals 25. From here, I need to get rid of that 32 in front of the x. So again, this is multiplication that's occurring. To undo multiplication, we divide. I'm going to divide both sides by 32, giving us x over y equals 25 over 32. Exactly what we were looking for in terms of our ratio once again. So again, since it's x to y, it's going to be 25 to 32 as our final answer. All right, next up, let's go ahead and work on some geometric mean. So we want to find the geometric mean between 10 and 40. Now again, geometric mean means that two of the numbers are the same, one denominator and one numerator within our proportion. Of course, these need to be on opposite sides of our equal sign. So we have 10 and 40. These will be our first term and our fourth term. Meanwhile, our second and third term will be the same number, the geometric mean. It's what we're trying to solve for. So in this case, it will be x for both. Because again, geometric mean means that the numbers that are kitty corner to one another, one being denominator, one being numerator, are the same number. So if we're trying to solve the geometric mean, it's going to be x. If they tell me what the geometric mean is, then I would plug in that number for it. Thank you. So therefore I have x squared equals 400. From here, to get rid of the square, I'm going to take the square root of both sides, and that will give me x is equal to positive 20. So the geometric mean is 20. And of course, if I plug that in, that'll give me 10 over 20 equals 20 over 40. Of course, those both reduce down to 1/2. So as we can see, 1/2 equals 1/2, and we're set. Let's try another geometric mean problem. Maybe, there it goes. So this time, 5 is the geometric mean between 3 and what number? This time they're telling us what is the geometric mean. So like in the last problem, instead of putting x for both of those, I'm going to put 5 in for both of those. Meanwhile, the other two terms, the first and the fourth term, will be 3 and an unknown number, our variable. So therefore, we're going to have 3 over 5 equals 5 over x. Again, we can see that we have our geometric mean occurring with those 5s, because again, they're repeating the same number. One's numerator, one's denominator, and they're both in different ratios. From here, we can just go ahead and cross multiply and solve. 3 times x is 3x. 5 times 5 is 25, so 3x equals 25. Lastly, we just solve for x by dividing both sides by 3, leaving us with our final answer. X is about 8.3. Now again, if they tell us what the geometric mean is, then those two numbers will be the same. If they tell us to solve for the geometric mean, then those two numbers would be the same variable. So again, it's very dependent upon whether they tell us that we have the geometric mean or if we're solving for the geometric mean. And that's why this time these aren't variables, they're the number 5, because they tell us it's the geometric mean. All right, let's go ahead and move on to our next one. This time we're going to be dealing with a proportion problem. It says, if 4 to 9 is equal to 5 to x, find x. If needed, round to the nearest tenth. So we want to round to the nearest 1 decimal place. Now again, these are just ratios, so I can set them up as fractions. We have 4 over 9 equals 5 over x. Well, at this point, we can just solve for x. We cross multiply, giving us 4x equals 45. And then if I divide both sides by 4, I will have x. Well, 45 divided by 4 is 11.25, but we're rounding to the nearest tenth. So I'd round up to 11.3. So x is about 11.3. All right, one more proportion problem, then we'll get into some triangle problems. Well, actually, I think we have a slope problem after this, but still, we're getting closer to the triangle problems. Solve the proportion for x. If needed, round your answer to the nearest tenth. This time we have x over 5 over 3x minus 4 equals 7 over 2. Again, if we have a proportion, we're just going to go ahead and cross multiply, and then we can solve. So cross multiplying, we'll get 2 times x plus 5 and 7 times 3x minus 4. Now looking at this, we're just going to start solving for x from here. And if we look, we need to distribute through the parentheses. So distributing will give us 2x plus 10 equals 21x minus 28. Now that we distributed, we're going to get all of our like terms on the same side and simplify. If I subtract 2x from both sides, 21x minus 2x will give me 19x. If I add 28 to both sides, 10 plus 28 will give me 38. So we'll have 38 equals 19x. From here, we're just going to go ahead and solve for x by dividing both sides by 19. And that'll leave us with x equals positive 2. And that'll be our final answer. That makes sense because 2 plus 5 will give us 7. 3 times 2 is 6, minus 4 is 2. So we end up with 7 over 2 equals 7 over 2, which is exactly what we were looking for. All right, next up, we have a slope problem. So they tell us answer the questions below. If needed, round to the nearest tenth, meaning 1 decimal place. They start by asking, what is the slope between the points 4, 2 and 6, negative 6? Now, if we recall, slope is written in a lot of ways, and they're all ratios. Slope is equal to rise over run, which is the y2 minus y1 over x2 minus x1, which is equal to delta y over delta x. Now, again, this triangle symbol. Within algebra, this is the Greek letter delta. And delta means change in. So this is the change in y, which is true because we're subtracting our y values, finding that change, over the change in x. We're also subtracting our x values, finding that change. So if you see this in algebra, it just means change in or change of. So just keep that in mind in the back of your head for later on. It'll be very useful as you get into the higher math classes over time. So we're going to go ahead and use our slope formula to find slope. That will give us, let's see, 2 minus negative 6 over 4 minus 6. If we see a double negative, of course that changes to a plus. So 2 plus 6 is 8. 4 minus 6 is negative 2. Simplifying down this fraction, we get negative 4 over 1. So therefore, our slope is negative 4, because we're rounding to the nearest tenth. Now, I'm going to keep this ratio, I'm going to keep the denominator as 1, as we talked about in 6.1, because if we're dealing with ratios, it's very important that we have a numerator and a denominator. Now, that will help us out for these next couple problems. For letter A, if the x value increases by 6, how much does the y value change? The hint is to set up a proportion with the slope. So one side of my proportion will be my slope, and then we're saying that the x value is increasing by 6. So x will be positive 6, and we're going to try and solve for y. So our proportion will be negative 4 over 1 equals y over 6. From here, we can cross multiply and solve. 1 times y is, of course, y. Negative 4 times 6 is negative 24, so y equals negative 24, which means if x increases by 6 in the right direction, y will decrease by 24 in the downward direction. Let's try out letter B. If the y value this time increases by 10, how much does the x value change? So again, this time we're setting up the same proportion, but this time we're switching these. So we'll have negative 4 over 1 equals 10 over x. Again, 10 is increasing, or sorry, y value is increasing by 10, so y will be replaced with 10. Again, we're solving for x, so we'll just go ahead and cross multiply and solve. So it'll give us negative 4x equals 10. Dividing both sides by negative 4 gives us x equals negative 2.5. So therefore, the x value will change by negative 2.5. All right, next up. Now we're moving into the triangle problems. So for this first one, for the following, find the missing side length. Round your answer to the nearest tenth. Now this is all on 6.5. So I'll have another video posted for 6.5 for you guys, but this is where you can learn about all of that information. And again, 6.5 is just dealing with 3 theorems on triangle similarity, and each of these is one of the theorems. I'll go ahead and wait because there's a leaf blower outside. All right. Sorry about that. Just want to make sure that I'm not being talked over, really. So, for this one, for the first one, in the first couple, within 6.5, we talked about keys that we need to look for within these types of problems. And one of the major keys for these types of problems is parallel lines. So if you ever see parallel lines, we can always use the side splitter theorem. Now the side splitter theorem means I'm going to split the sides of my triangles so I can set up my proportions, and my ratios will stay the same on either side. They'll stay on the same side. So the first thing I did is I added this 4 in here. The reason I added the 4 is because 10 plus 4 equals the whole thing, which is 14. Meanwhile, I just did our unknown side. I gave it a variable. I called it x. Next, I'm going to split the sides. And to split the sides, I'm going to be going through the parallel lines. So I'm going to draw a line through the parallel lines so I can set up and split my sides. This will allow me to set up a proportion. And again, when I'm setting up my ratios within the proportion, I'm going to stay on the same side because they're split now. So 4 and 10 are one ratio. And you can see that in blue. And then we also have x and 25 as our second ratio. You can see that in the red. So that's how we split up our sides. And again, the line that is splitting goes through the parallel sides. From here, we can cross multiply and solve. This will give us 10x equals 100. Dividing both sides by 10, we get x is equal to positive 10. So that missing side length is just 10. Here's our next theorem. And again, we're going to do the same exact concept. We see parallel lines. That's our key. If you see parallel lines, split the sides through. Now, if I notice here, I have a missing side length. The full thing is 20. I have 8 as part of it. Well, 8 plus what will give me 20? That'd be 12. So I go ahead and I split through the parallel lines. So it's going through all 3 parallel lines. And then I can set up my ratios from here. If they're on the same side of that split, they have their own ratio. So I have 8 over 12 equals 18 over x. Again, 8 over 12 is equal to 18 over x. Both 8 and 18 are within the same parallel lines, so they are both numerators. 12 and x are within the same parallel lines, so they're both denominators. From here, we can go ahead and solve for x by dividing both sides by 8, giving us x equals 27. So we covered those 2 theorems. We have one final one from 6.5, and that's the angle bisector theorem. Now, the way that I can tell what I'm going to use on this specific problem is because I notice that we don't have parallel lines. So I can't use the side splitter theorem. That's out. I'm done with that. But I do have 2 angles that are congruent, and they're split by a line, meaning this line segment is an angle bisector. So we're going to use the angle bisector theorem. Now, with the angle bisector theorem, it's very important for us to label our sides. Now, of course, we can see that this part is 6, this is 3, this is 8, and this is our unknown side, x. Now, when I'm labeling my sides, I'm going to label them as opposite of my angle or adjacent to my angle. I will never use the angle bisector, so just ignore this side of the triangles. We don't want to use it. It's not useful for us in this type of problem. So using opposite over adjacent, we're going to go ahead and name the sides. If it's opposite, I need to go through the triangle to get to it. If it's adjacent, it's going to be right next to the angle. So 6 is opposite because I need to go through the triangle. 8 is adjacent. On top of that, 3 is opposite, and x is adjacent. For my ratio, I'm using opposite over adjacent, so that will give me 6 over 8 is equal to 3 over x. From here, we can cross multiply and solve. This will give us 6x equals 24. And then dividing both sides by 6, we're left with x is equal to positive 4. That is it for 6.5. Again, if you're curious about 6.5 and need to look back through it, it should be another video for just that. Next up is one of the hardest topics of Unit 6, and that's altitude to hypotenuse. So we have our altitude going on our hypotenuse here. within this right triangle. And I know it's an altitude because it's intersecting at 90 degrees, but what this does is it creates three similar triangles. The small triangle on the on the right side, the medium triangle on the left side, and then the whole triangle overall. All three of those are going to be similar. So what we're going to do here, we're going to start by solving for letter A. It tells us that AD is 4, BD is 6, and we want to find CD. So we start by thinking, which triangles is CD on? Well, CD is on our medium triangle for sure. And this other information, AD being 4 and BD being 6, well, those are both on the small triangle. So we have information on the small triangle, at least two sides, and then we have the medium triangle that we're working with as well. We have X and, oh, we also have BD, so we have two sides of that. So we're going to use the medium triangle and the small triangle. Now what I'm going to do is I'm going to take both of these triangles and I'm going to draw them down here so that they have the same orientation. They're facing the same way. So our medium triangle will have a long leg of X and a short leg of 6. And our small triangle, I just moved that down. It has a long leg of 6 and a short leg of 4. Now for my ratio, I'm using the medium triangle is equal to the small triangle. So the medium triangle's ratio will all be on the same side. The small triangle will all be on the same side. Using long leg over short leg, I'm going to have the ratio of X over 6 equals 6 over 4. Again, this is all from the medium triangle. This is all from the small triangle. We know that we're doing it correctly if we have a geometric mean occurring. So from here, we can just go ahead and solve. Cross multiplying, we get 4x equals 36. And dividing both sides by 4, we get x is equal to 9. Since CD is x, we can say that CD is equal to 9. All right, next up, part B. Part B here. This time, AC is 6, AD is 3, and we want to find AB. So think about what information that we have on this triangle. Well, if AC is 6, that's the hypotenuse of the large triangle. AD is the small leg on the small triangle. So we have information on the large and the small. And then lastly, AB is the hypotenuse on the small triangle, and it's the short leg on the large triangle. So we have information on the small triangle and on the large triangle. So those are the triangles that we'll use. I'm just going to go ahead and bring them down so that we can draw them out and so that we can see all the information. So I have my large triangle and I have my small triangle. My large triangle has a hypotenuse of 6 and it has a small leg of x. Meanwhile, my small triangle has a hypotenuse of x and a small leg of 3. So what that means is I can set up a ratio of hypotenuse over small leg. This will give us 6 over x equals x over 3. We know that we're on the right track. We can check because we have a geometric mean. So we're doing it correctly. From here, we go ahead and we cross multiply and solve. This will give us x squared equals 18. Taking the square root of both sides will give us about 4.2. And again, you can use that calculator over here in order to enter in those square roots. All right, let's try one last altitude on hypotenuse problem. Solve for z. So we have z here. And looking at the information, z is on our small triangle. We also have 4 on the small triangle, so we have the short leg and the hypotenuse on the small triangle. Meanwhile, z is also on the large triangle overall, the whole thing. And further, I can find the hypotenuse by adding 5 and 4 together, giving us a hypotenuse of 9. So drawing this up, we have the large triangle and the small triangle. So we're going to be using both of those. Now, If I take the large triangle, again, the short leg is Z, as we can see, and the hypotenuse is 9. Meanwhile, on the small triangle, the short leg is 4, and the hypotenuse is Z. Well, again, we're going to do the same setup. We're going to have large triangle on the left side, small triangle on the right side, and we have hypotenuse in short leg. So that's the ratio that we'll use. So this will give us 9 over Z equals Z over 4. From here, we can cross multiply and solve. This will give us Z squared equals 36. And then taking the square root of both sides, we get Z is equal to positive 6. So that'll be our final answer here. Lastly, our final question deals with Pythagorean's theorem. It says, do the following sides make an acute, right, or obtuse triangle? So we have 3 sides. We need to determine which type of triangle this is. Now, if we recall, if a squared plus b squared is greater than c squared, then it's going to be an acute triangle. I need to add the squares in here. If a squared plus b squared is less than c squared, it will be an obtuse triangle. And if a squared plus b squared is equal to c squared, it will be a right triangle. Just as a note, c is always the longest side length. So I start this off by writing out our equations. 6 squared plus 9 squared is mystery to 10 squared. 10 squared plus 24 squared is mystery to 26 squared. And lastly, 5 squared plus 7 squared is mystery to 11 squared. From here, we're just going to go ahead and solve. For our first one, 6 squared is 36, 9 squared is 81, 10 squared is 100. So that'll give us 127 is greater than 100. Because obviously, if I add these two numbers together, it's going to be greater than our third side squared, which makes this an acute triangle. If the two sides are greater than our third side, it's acute. Next, we do it with the second triangle as well. This time we have 10 squared plus 24 squared equals 26 squared. So will give us 100 plus 576 equals 676. Well, of course, 100 plus 576 is equal to 676 once again. So since they're equal, it's a right triangle. And then lastly, you could probably guess it because it's been color coordinated so far. Let's go ahead and try it out. This will give us 25 plus 49 and 121. Well, 25 plus 49 is 74, and that is less than 121. So therefore, this is an obtuse triangle. That is it for our Unit 6 review. If you have any questions, please let me know. But thank you guys